2/8. So by now you all have your notes out. We're going to quickly go through this applications of proportions. So we did proportions yesterday. And a proportion is a what equals a what?
Ratio equals a ratio.
Yeah, nice. A ratio equals a ratio. So it's always going to be like one fraction equals another fraction. So the way we can apply that one is going to be similar figures. So if you have similar figures, they're the same shape. Ooh, but different. You want to get the second one? Nice, sizes. So I have two triangles there that all the angles should be the same. So my example, the thing that I think of is my brother made this sweet model of a F-14 Tomcat plane when we were little kids. And he got like the good model set where you used the glue and you had to paint it. And I got the truck, you just snapped the pieces together, and I was jealous. But if this model was a decent model, I don't know, it was a 1 to whatever, 1 to 37 model or something. So then if this is 1 foot long, a real plane would be 37 feet long. If it was a 1.5 feet wide, then a real plane would be, I forgot the number by now, but it'd be the same proportions as like the real plane. It'd look the same, it just would be a small version. Yes? Okay, so we have two triangles. We have two that are the same shape. They have the same angles. I want to point out that the way they write them is like triangle ABC is similar, so it's kind of like half of a squiggly equals, half of an approximately equals. That's a similar sign to triangle EFG. But you have to put them in order. So if I were to do like triangle ABC, so I'm starting at the top and going around, you have to list your second triangle. Well, if angle E is congruent to, equal to angle A, you list that one first. So if I did ABC, then I have to do EFG. Good? If we were to have something that was like a square or a pentagon or something like that, it doesn't matter where you start with your points. Do I start there and go this way? Do I start here and go this way? But you have to go around the object. So if I had like points A, B, C, D, E, I couldn't list it as though it's A, C, D, E, B. You know, you have to go around the object for order. We okay on those? All right, enough of that. Let's just actually do this thing. So we have the order. There's a couple ways you could do the ratios. Say we're trying to find x here. So we could say on the first triangle, we say the ratio is 4 to 10. Then what does my second fraction look like if we're trying to find x?
6.5 over x.
Nice, 6.5 over x. Because 4, the side 4 corresponds with the side 6.5, so they'd have to both be in the numerator. And side 10 corresponds with x, so they'd have to both be in the same spot. You could, if you wanted to, flip both those fractions and have 10 over 4 equals x over 6.5. Totally fine either way. Perhaps the easiest is to cross multiply. So 4x equals 10 times 6.5. You guys still tracking with me? So we'd have 65 on the right and a 4x on the left. So if we wanted to find what x equals, we would... Nice. So to get x by itself, they multiplied by 4. We have to divide by 4. So x then would be 16.25. Heard some murmurings from people. So. Does that work for you guys?
Yeah.
So I'm guessing most of you remember that from last year. If not, I'll gladly go over it with you when we're working on homework. If we go to the back. All right, so we want to look at what happens when we have similar figures, when we do these scale changes, same object, but one's bigger, one's smaller. What happens to those distances, such as circumference, and areas with those? But before we do that, I need to squeeze in here a scale factor. So SF equals a scale factor. And I could say that is what the original object is multiplied by. So for my example, trying to play off a book title, Tale of Two Circles, say you have two circles, one has twice the radius of the other. So if we have a radius of 2 and a radius of 4, for example. So when we do those, we know that these are going to have a scale factor of 2. Now we could take our original length of 2, when we multiply it by 2, it gets us up to the 4. So I'm going to quick crank through circumference calculations for both of those lengths. So my circle with radius 2, circumference is 2 pi r. So the circumference then would be 2 times pi times 2 or 4 pi. And we could actually take and multiply pi by 4. We get like 12.5-ish, 12.6. But I'm just going to leave it as the 4 pi, save a little bit of time. So that's going to be my first circle here. My second circle I'll do in orange. So same original equation. Circumference is 2 times pi times r. So I have 2 pi, but now my radius is 4, which gives us then a circumference of 8 pi. So what we found is if one is 4 pi and one is 8 pi, we just multiplied by 2. And that's true when we have a problem where the scale factor is 2. So then we could write something like this. I'm going to put a star by it for dramatic emphasis. Hopefully it'll make it pop off your notes. You could put an arrow to it if you wanted to. But the whole point of this is new lengths, when we have these similar figures, new lengths equals the original length times the scale factor. And don't let me doing an example with circumference and then talking about length confuse you. Circumference is just the length around a circle, the distance around a circle. But now if we do that same thing for area, do we end up with the same result? So I'm going to say the area of my circle is pi r squared. So for our first circle, we have a radius of 4. Oh, first circle was a radius of 2. Let me go back and fix that. So we have 2 squared times pi, or in other words, the area of my first circle is going to be 4 pi. Interesting, it looks the same as the length, but this is actually 4 pi, like square units. But anyway, don't let that confuse you. I probably shouldn't have even mentioned it. But my second circle, area is pi r squared. But now we have a radius of 4. So now we get up to the area of the second one is going to be 16 times pi, or pi times 16. So how much bigger is the orange one with the radius of 2? Well, 4 times 4 gets me up to 16. So my brain is one step ahead today. That's what I'm going to claim. So I'm multiplying by 4, but the scale factor was only a 2. So if we want to take and kind of make a rule for this, we could, and again, dramatic emphasis drawn to it, maybe with an arrow, maybe a star, or learn this, but new areas equals the original area times the scale factor squared. Because if we would do a 2 squared, that would give us the 4. So those kind of pop up in some of the homework questions, so keep those in mind. It'll make the homework better. Let me know if you have questions. One